Hey guys, this is 9-4. We're going to get all of the examples into one day, and I will try to get as many in this lesson or in this video, but I might have to break it up into two. Alright, so rational expressions, we are going to simplify them, state their restrictions, which is going to be your points of discontinuity, and then it's also going to multiply them and divide them. Okay, so here we go. Looking at example 1, you need to either A, factor the trinomials, or if they are already factored, then you just want to cancel out, any like expressions that you may have. So the textbook author in this one factored it down, and then we have x plus 5 and x plus 5 in the numerator and denominator, so those cancel out, and you're left with x plus 5 over x plus 4. But when we look at restrictions, we have to look at what we started with in the original problem and what we had in the most simplest form, because anything that is going to cause your denominator to be equal to 0 at any point is going to be a restriction. Alright, so let's take a look at the one for your notes. We have simplify x squared minus 6x minus 16 all over x squared plus 5x plus 6. So we are going to factor the x squared minus 6x minus 16. Factors of negative 16, that will give you negative 6, are negative 8 and positive 2. And then we have x squared plus 5x plus 6. Factors of 6 that give you 5. That is going to be 2 and 3. Because 2 times 3 is 6, but 2 plus 3 is 5. Alright, so now writing this expression as to, or the rational function as to factored expressions in the numerator and the denominator. In the numerator, we have x minus 8 and x plus 2. And in the denominator, you're going to have x plus 2 and x plus 3. Alright, so now we want to cancel out any like factors that we might have. So then we have x plus 2 and x plus 2. Those are like terms. So that is going to cancel out, and we have in the numerator x minus 8 all over x plus 3. Okay. So now you want to go ahead and take a look at your denominators. And any term that is in the denominator, any expression, you have to set both of those equal to 0, and then that would be your restriction. So we have x plus 2 equals 0. So subtract 2 from both sides, and we have x is negative 2. X plus 3 is 0. So you subtract 3 from both sides, and you get x is negative 3. Alright, so the final answer then is x minus 8 over x plus 3, and x cannot equal negative 2 and negative 3. Alright, hopefully that makes sense. Again, remember you have to check to the original. You cannot just take into consideration the x plus 3. You have to also look at the x plus 2 that we had canceled out. Alright, so now going on to the next slide. Example 3, we're skipping over number 2. And similar process, you have to factor both the numerator and the denominator. And then we're going to multiply across, and if there are common factors in the numerator and denominator, then they will cancel out. Okay, so looking at the one for your notes, there's a whole lot of factoring going on here. So in this top left fraction, this one is going to require the Xbox method, box method, grouping, any of those. The x squared minus 25 is a difference of squares. So if you remember that property, it will save you time. Remember I said it would. And then we have the 3x squared minus 7x plus 2. So we're going to have to do the group X box method for that one. Alright. So looking at my first fraction, my first rational function, I'm looking at the numerator. We have 3x squared plus 5x minus 2. Multiply your first and last terms together, and that's going to give you negative 6. And then in the denominator, not the denominator, in the bottom, you are going to put this number, which in this case is 5. What are factors of negative 6? That will give you a 5. So we would have a 6, and we would have a negative 1. 6 times negative 1 is negative 6. 6 minus 1 is 5. And then we divide the factors, and this is going to be divided by a. And our a in this case was 3. So 6 over 3 reduces to 2 over 1. So for this first one, we would have x plus 2, 3x minus 1, all over the x minus 5. Alright, so now we need to find out what the numerator here would be. That's a difference of squares. So that would be x minus 5 and then x plus 5. The denominator is going to be very similar to this one over here. So we would have 3x squared times 2 is going to give you 6 up top, and then down below is going to give you negative 7. So factors of 6 that will give you negative 7 would be negative 6 and negative 1. And then we divide these factors on the side by the a value, which is 3. And so then negative 6 over 3 just gives you negative 2 over 1. So in the denominator over here, we have x minus 2 times 3x minus 1. Alright, so now we want to look at what we have and cancel out any like factors. So we have x plus 2 here, and I have an x minus 2. That won't work. 3x minus 1. Alright guys, hopefully I've got that corrected. I'm not 100% sure, but we'll go from there. Alright, so again, you want to set each of the expressions in the denominator equal to 0, and that is going to give you your x values, your zeros. So now we write that over here. We have our simplified form, x plus 2 and x plus 5 all over x minus 2. So then the restrictions are x cannot equal negative 5, 2, and negative 1/3. And I looked at the wrong expression. This would be positive 5. Okay. Alright, so any questions on how to do that, just send me an email. You can tell I'm used to doing it that way. Alright, and next example that we are dividing rational functions. So you're going to do the same thing, but it's a little bit more complex because you have to check the two denominators of the original function, and you also have to check the